we're going to say limit as x goes to 0 of p, as x goes to c of p of x. Look, p of x is just like f of x. We've been dealing with f of x as in general a function, a general formula of function. But a polynomial is also a function. So we said p of x. So limit of p of x as x goes to c, right, is equal to what? Which rule did we apply for this? Among the rules that we talked about, which rule should we apply for this? Huh? There are two rules involved. If we want to determine this limit, there are two rules involved. Tell me the two rules. Huh? First,
Derivative.
we have x multiplied by a constant, so the multiplication by constant applies, right? Remember we said limit of k x as x goes to c equal to k multiplied by limits of x as x goes to c, right?
Right.
So first, this should apply. What is the second one that must apply over here? Limit of f of x plus h of x equal to what? Limit of f of x plus limit of h of x. Didn't we do that? What do we call this? Huh? What do we call this limit? What do we call this limit?
L plus m.
Yes, this is
Teach me.
limit of the sum of two functions is the sum of the limits. Here, limits of a function multiplied by a constant equal to limit the function multiplied by the constant. Here, limit the constant inside equal to the constant outside, and we go to limit of x as x goes to c, because x going to c or not is not going to affect the constant. So we take the constant outside, right? And we get it this way. And limit of the sum is the sum of the limits. Okay? So we use these two. Please be careful, because you may get questions like this in your quizzes or exams. So try to relate everything you studied with everything you're going to study. Okay? They're all interrelated. The intricacies can be really difficult if you don't study right away, if you don't remember things. So everybody is comfortable? So we can see that we took this one first and we looked at what? The limit of what? The limit is over here, right? Correct? The first one is over here, right? So we took a sub n outside and we got what? This is what? Which rule we use for x to the power n, the exponential? Which rule we use for x to the power n? Multiplication rule. It's just like x times x, right? Limit of x times x, limit of x times x. Okay, let's say as x goes to c of, let's say, x squared, x cubed, whatever, is equal to what? Limit of each one separately multiplied, right? Limit of x squared as x goes to c multiplied by limit of what? X to the power 3 as x goes to c, right? We talked about this, right? So
Yes.
you raise to appear, the point is just like multiplication. So you use what? You use what? The multiplication rule. Once you do that, it will give you what? A, and then what? This is the limit of c raised to the power n, right? Which is c raised to the power n. In other words, when you have something like this for a polynomial, you don't have to think. The limit is what? As x goes to c. Just go ahead and plug in instead of x, you plug in what? C. That's it. واضحة? What's the difference between this one and this one? X replaced by C. The rest is the same, correct?
Yep.
Teacher, can we take some examples with numbers?
Okay. Limit of 3x square. Okay. 3x square as x goes to c equal to 3 times limit of x square as x goes to c, right? But this is equal to what? Limit, we have the 3 over here, right? It has limit x goes to c of the first x, and then limit as x goes to c of the second x, right? Because there are two x's, right? Limit of x times x is equal to the limit of the first x multiplied by the limit of the second x, correct? What is the limit of the first x? We have the 3 outside. The limit of the first x is what? Is c, correct? You just replace, right? And the limit of the second x is what? Is c.
C.
So this will be equal
Okay.
to 3 multiplied by c squared, which is this. Okay? Okay? Everybody?
Yeah.
Okay.
Comfortable?
Clear so far.
Yeah, please don't hesitate to ask questions, please. Okay, the quotient rule. We said limit of the quotient, okay? We have to have a condition. What's the condition? The denominator should not be equal to 0, right? So the limit of the quotient, limit of the quotient is the quotient of the limits. Isn't this the limit of x in the numerator? Isn't this the limit of x as x goes to c for the numerator? This one, isn't it the limit? And I could rewrite it like this. It's limit as x goes to c of p of x divided by limit as x goes to c q of x. You know what I mean? It's like this. Limit of the whole thing is limit of the numerator by itself divided by limit of the denominator by itself, okay? And that's going to give you what? Limit of the numerator will give you just p of c. Limit of the denominator will give you what? Q of c. Correct?
Yes.
Good. Let's get going then. Here is a question, and I'm sure that you will be tired trying to do this time and again, but it's the same. We're trying to see if x goes to what? This is a limit when x goes to what? Limit as
To
x.
0.
Yes, excellent. This is saying limit as x goes to 0. And this is the function f of x, right? So let's plug in 1. Let's plug in 1 to see what we're going to get here. So this is the square root. It will be a square root of what? Square root of 1 plus what? 100, right? Minus 10, right? This is the numerator, right? Denominator is 1, so don't worry about it, right? So 1 plus 100 is 101, right? So we have what? The square root of 101 minus 10 divided by what? Divided by 1, which we know. Right? If you do math, this will be like 0.05. It's almost 0.05. Wait, we do have it here. Yeah, it's 0.0949. Okay, you see it? If you do the math, it's just this. Now reduce from 1 to 0.5, negative or positive, because we're doing the square root anyway, so it doesn't matter. 0.5, when you reduce it to 0.5, you look, the number will start going down. F of x is between g of x and h of x. See, it's between. It will not be greater than g of x, and it will be greater than g of x, but it will not be greater than h of x. It will always be less than h of x for all x's, right? If that's the case, then we can say that if we are taking x equal to c, okay, we suppose that limit g of x as x goes to c equal to limit h of x as x goes to c. equal to L. Okay, what does it mean? Let me go back to the previous one, or I'm recording. Let me just do it here. Let's suppose that this is the first function and this is the second function, right? And the one sandwich is right inside. Okay, what we're trying to say is that limit of this function, okay, and limit of this function, if these functions happen to meet in a point called C. So we're going to call this point C here, this point C here. If these two functions meet at C, that means what? The limit of these two functions will be equal to what? L. So the limit of the first function equal to L. So limit of the first function, whatever its name is, let's say G as x goes to C is equal to G of C. Okay? And if we take the limit of this one, I don't know what we call this one, H. If you take the limit of H, this is H, as x goes to C of H of x is going to be equal to H of C. Okay, and H of C is equal to L, and G of C is equal to L. Why? Let me just put this one like this. This is L here, okay? And we have the two graphs. Let's say this one graph is something like this, and the other graph is something like this. They meet somewhere here, and then they disappear. So this is our what? This is our G of x, and this is our which one? This is our H of x. Okay, this is our H of x, and this is the point what? This is the point C, correct? So we're saying limit of G of x as x goes to C is L, because this is the point. G of C, what is G of C? Equal to L, right? G is a graph. What is the value of G when x equal to C? Equal to what? L, right? Shabab, this is x-axis. This is the y-axis. This is a function, okay? I'm asking you, let's suppose that this point is equal to, for example, this point is equal to 1. If I ask you what is G1, G of 1, G of 1, you go up until you meet what? You meet the curve for G, and you tell me G of 1 is equal to whatever the value is, correct? Huh?
Yep.
If I want G of 1, I have to put a line up, right? And then I have to put a line there, and I will tell you maybe L plus something. I don't know what it is. Let's say L plus 1. But you see H and G, two functions, they meet at this point C, right? So what's the limit of G of H, G of x? What is the limit of G of x when x goes to C? That means x keeps moving. This is the x-axis, so this is x large. Keep moving, moving, moving until x reaches C. The x coordinate is equal to C now. So what's the limit as x approaches C? Equal to what? Equal to L, right? This level is the level of L. Correct, Shabab? Huh?
Yes.
So limit of G of x will be equal to L. What about limit of H of x as x goes to C? This is H of x. You can see H of x, trace it. Also, it comes what? At
Same.
C. Same. So as x goes to C, the limit is L. Both of them, their limit is L, right? What about the function inside them? The function inside them, between them, which is called f. What is the limit of the function inside them as x goes to C?
Also same.
Yes, it's going to
Same
be
point.
correct. Very good. It's going to be the same. Excellent. So let's go over here. That's it. So what we have is, let's take a look at this. It says what? Limit of G of x as x goes to C equal to limit of H of x as x goes to C equals to L. Then our conclusion is what? Limit of f, which is sandwich between these two, limit of f of x must be equal to L. Correct, ya shabab? And the sandwich theorem is
Yes.
very important. It's very important. I'm going to go ahead and use the sandwich theorem today to show you how it is. Before we get to the next, this section is not included. Okay, so let's take advantage of the time and try to use the sandwich theorem. I want us to prove, let me see what. Let's say limit, this is going to be difficult, but anyway, let's try to do it. Limit as, let's say, theta equals to 0 of sine theta over theta. What do you think this limit will be equal to? Oh boy. What do you think this would be equal to? Huh? Shabab?
0 دكتور 0
Equal to 0? I said as theta goes to 0. So any other answer? Any other answer?
Undefined.
undefined دكتور 0
Okay,
undefined.
good. Let's go ahead and use trigonometric. I'm going to go ahead and use trigonometric. Let's see. Like this. Okay, let's try to draw a circle now. I don't know, this is not a circle, but anyway, let's just think about it as a circle. Okay? Shabab, معي?
Okay, fine, Doctor.
Back.
This is the origin. So we're saying the radius is 1. Okay? So this is 1 and this is 1. The radius is 1. All of this is 1. Okay? What I'm going to do, I'm going to call this one
Okay.
angle theta. Okay? If I call this angle theta, then I'm going to go ahead and say that the length of this one is equal to sine theta. The length is equal to sine theta. Okay? The length of this one is equal to how much? Sine theta, right? What about this, the length of this from this point? From this point on, the length of this is equal to what? If that's equal to sine theta, it's going to be what? Cosine theta, right? Shabab, معي?
Back.
Okay, so everybody sees what I'm talking about.
Yeah, this is sine theta.
If you don't,
Cosine theta.
yes, why that one will be cosine theta? Because sine square theta plus cosine square theta equal to 1. And we said the radius equal to 1. So this is a hypo, right? So this will be cosine theta. Cosine theta. So cosine theta is from this point to this point, correct? صح يا شباب?
Correct.
Okay.
Correct.
What I'm going to do is I'm going to go ahead and take a vertical line up from this one. Okay? And I'm going to connect it with this. I'm going to call this one, guess what? Tan theta. Right? Isn't this tan theta? What is tan theta? Tan theta is equal to what? The opposite divided by the adjacent. The adjacent is what? Equal to how much? The radius is what? Radius is how much? We said
Cosine
radius
theta.
equal to 1. Didn't we say the radius equal to 1? And this is the
Yes.
adjacent is the radians. So what is tan theta? Is equal to the opposite divided by 1. So the opposite is tan theta, right?
Yes.
Everybody? The opposite is tan theta. Is that right? Everybody sees that.
I don't understand how you got tan theta.
Okay. Don't look at what the value of this one is. Okay. Give me tan theta for the larger triangle. What's tan theta for the larger triangle? The opposite divided by what? The adjacent, right?
Right.
The opposite is equal to what? We call it tan theta. So this is a sector. The area of the sector of the circle depends on the angle, this angle. This angle, we take the ratio, this is what? Theta over what? 2 pi, right? This is theta over 2 pi, correct? The angle 90 is what? Pi over 2, right? Over 2 pi, the ratio, correct?
Yes.
Yes.
180 will be pi over 2 pi, the ratio, right? So the angle 180 is half, correct? Half the circle. The angle 180 is half the circle, right?
Yes.
The angle pi over 2, if you take the pi and the pi, the 2 will go down, is 1/4, right? Correct?
Yeah.
Yes.
So what about this angle? This angle is what? Is theta, right? Theta divided by 2 pi, correct? That's the ratio, right?
Theta must be in radians, right?
Yeah, just leave it in radians now. Let's go ahead and multiply this one by the area of the circle, pi r squared, correct? So this will give us what? This is gone with this, and it will be what? Theta times r squared divided by 2, but r squared is equal to 1. So the area of this sector is what? Theta over 2. Correct? The area of this sector is theta over 2. Correct? This one. Everybody sees that? Okay. If that is the case, let us take the area of the bigger rectangle, the bigger triangle. What's the area of the bigger triangle? The opposite is height. It is tan. The adjacent is 1. What do you think its area is? It will be tan over 2. Correct? Shabab, the area of this triangle is what? The height multiplied by the base divided by 2. صح? Shabab?
Yes.
So the height is what? Tan theta. The base is 1. So it will be tan theta times 1 divided by 2, right? So it is tan theta divided by 2, correct? Shabab? Okay, now let's take a look at the smaller triangle inside. The smaller, what is the area of the smaller triangle inside? This angle is 90. What's the area of this? The height multiplied by the base divided by 2, right?
Right.
What is the height? Sine theta. What is the base? Cosine theta. Divided by 2, right? So this will be what? Sine theta, cosine theta, divided by 2, right? Which area is the smallest? Is it the inner triangle, or the sector, or the larger triangle? The larger triangle is what? Greater than the sector, right? This is the area of the sector.
Right.
And the sector is greater than what? The smaller triangle, right? Correct? Shabab, صح?
Yes.
Now, aren't we sandwiching this area? We're sandwiching this area, correct? معي يا شباب؟ We're sandwiching this area. لأنه حاطينها من شمالها ومن يمينها، صح؟ Okay, I want us to multiply by 2. If we multiply by 2, what are we going to get? We're going to get what? Sine theta, cosine theta, less than what? Theta, less than tan theta. Right? Oh, God, stupid. Gets to its stupidity. Okay, so this is tan theta. Everybody sees it? This is tan theta. Now, what I want to is I want to divide every term by sine theta. What am I going to get on the left? Cosine theta, right? Less than what?
Yes.
Theta over what?
Theta
Over sine theta.
sine.
Okay? And this is going to be less than what? Tan theta is equal to what? Tan theta. Sine theta over cosine theta, right?
Yes.
So when
Right.
we divide by sine theta, we get what? 1 over cosine theta,
Because
right? Now let us do upside down for each one of them. It will be what? Cosine theta, right? It will be greater than sine theta over theta, right? And this will be greater than what? Huh? Oh, sorry, this will be 1 over cosine theta. If we do upside down, this will be 1 over cosine theta. And this will be cosine theta. Cosine theta, right? Let me just change that one to, change this to 1 over, not sine. This will be 1 over. Oh. Okay, so this will be what? Where are we? Yes, we're right here. This will be 1 over cosine theta, right? And this is cosine theta. Everybody see that? Now, let's take the limit as theta goes to 0 of this part. What will it be? As theta goes to 0. Cosine 0 is equal to what? 1, right?
Yes.
So this will be equal to 1. It will be greater than, we will put sine theta over cosine theta here. Oh, sorry, tan theta over theta. Where am I getting the cosine from? I'm going to delete it. And this will be greater than what? Cosine theta. What's cosine 0? 1, right? Let me just change what I made the mistake here. This is not divided by cosine, divided by okay, this is divided by theta. Is everybody following?
Yes.
Yes.
Okay, now
Sure.
this
انا ما فهمت من وين انت جبت الساين كوساين اوفر 2 هذه ما عرفتها.
اي واحده فيهم؟
اللي فوق هذه ساين كوساين اوفر 2 عشان تطلع هذه الايكويشن. من وين جبت ساين كوساين اوفر 2؟
what is the area of this triangle inside؟ هي ايش؟ القاعده ضرب الارتفاع. القاعده كم؟ كوساين ثيتا. الارتفاع كم؟ ساين ثيتا. كوساين ثيتا ضرب ساين ثيتا divide by 2.
that makes sense.
Okay. So now we took the limit of this and it gave us 1, right? We took the limit of this, gave us 1. That means the limit of what is inside as x goes to 0, limit of sine theta over theta as x goes to 0 is equal to 1. صح? It is sandwich. صح يا شباب? I'm going to write it over here clearly. So we have what? We have 1 greater than limit as x or as theta goes to 0 of sine theta, sorry, over theta is greater than 1. Okay, so it's 1 is greater than this and this greater than this. That means this is equal to 1. Okay. If you want to make it a little bit more clearer, you can say greater or equal to. But anyway, this is a sandwich. So you're taking at the limit in here. The only justification is that this limit is equal to 1.